This program is an operational demonstration of the Grass Valley Group Model 200 production switcher. It was conceived to help operators powerful features of the Model 200. And by design, this presentation should give just about everyone a hands-on feeling for what it's like to operate the Model 200. The program is divided with the corresponding number of the segment appearing in the upper left-hand corner of this tape as an index. These numbers will help when shuttling to a particular topic of interest. The segments are 1. Control panel layout. 2. Cross-point bus operation and auto delegation. 3. Transition control and preview. 4. Wipes, including standard patterns, the enhanced analog option, and the matrix option. 5. Keys, including the control area, linear, and luminance keying, chroma keying, and preset patterns. 6. Downstream keyer. 7. Creating special effects. Now, let's begin this demonstration of the Model 200 production switcher. First, an overview of the control panel layout, starting with the Mix Effects systems. Notice that Mix Effects 1 is shown in yellow, and Mix Effects 2 is shown in orange. Both Mix Effects are identical, with the exception that Mix Effects 1 can be re-entered on the key buses or either background bus of Mix Effects 2. To highlight this, we have used the yellow buttons to identify Mix Effects 1 re-entry into Mix Effects 2. Each Mix Effects is fed by 4 cross-point buses, each having 20 common primary sources. The bottom or lower bus in Mix Effects 1 is the B background bus. This bus provides the next background source as a result of our next background transition. Above the B background bus is the middle row of push buttons of the A background bus, which is used to select the background currently contributing to that Mix Effects video output. The top row of push buttons, the key buses, provide control of the same 20 primaries common to the A and B background buses, and 4 additional sources are available as external key fills. The key bus push buttons actually control 2 buses, one for each of the 2 keyers in the Mix Effects. The bus is delegated to the keyer when that keyer is selected for use. There are similar buses in Mix Effects 2. The key buses, the A background bus, and the B background bus. Each Mix Effects has a key control area, where features of a key are selected and adjusted, and a transition control area, where transitions are performed between one effect setup and the next. Notice that the relative positions of the control areas are reversed to avoid conflict between the lever arms. The Model 200 has 9 matte background generators controlled from the matte control panel. Controls include hue, chroma, and luminance. These controls are used to adjust each of the 9 matte generators. The Model 200 also provides 5 mask generators. These mask generators are used to limit or mask each of the 5 keyers in the Model 200. Chroma keyer hue is delegated and controlled from this point. In the lower right-hand corner of the control panel is the downstream keyer. These panel controls can be subdivided into transition control, key control, and the downstream background selector. With the downstream background selector, Mix Effects 1 or Mix Effects 2 can be chosen as the background to this keyer. Downstream key source selection is made using the DSK key bus row of push buttons, and Fade to Black provides auto transition and cut to black. The right-hand section of the control panel is the wipe control area. From this point, all modifiers and wipe selections are controlled for both Mix Effects 1 and Mix Effects 2. The two Wipe Select push buttons determine which Mix Effects wipe system is currently under control. Again, yellow is used for Mix Effects 1 and orange for Mix Effects 2. To the left of the wipe control area is the Safe Title selector, allowing us to turn the center or box Safe Title display on or off. Below the Safe Title controls are the enables. From here, the editor serial port, the general purpose interface inputs and outputs, and the serial peripheral port can be turned on or off. Below the enables is the preview selector, allowing us to monitor the program video of Mix Effects 1, the preview output of Mix Effects 1, program output of Mix Effects 2, preview output of Mix Effects 2, and the downstream keyer preview output. To the left of the enables and preview selector, we find the EMEM Effects memory system. The Effects memory system provides 30 standard registers in 3 banks of 10 registers, selected with the bank button. We can also learn or recall one level at a time or a combination of levels. The Streamline Effects Controller option provides the ability to modify effects memory registers by adding attributes, program timelines, program keyframes, store data onto a floppy disk, and access and change personality setups in the Model 200. The disk drive is also included as part of the Streamline Effects Controller option. This row of display windows allows the user to label Model 200 inputs being fed by Horizon router outputs. The Horizon Multi-Destination Display option can label 1 or 2 sets of 8 inputs. Below the Multi-Destination Display window is the Local Auxiliary Bus panel. This panel allows selection of any of the 20 primary sources: Mix Effects 1 and Mix Effects 2 program video, clean feed video, program video output, and 2 direct inputs. These 2 direct inputs are available only on the aux buses. There are, in fact, 4 aux buses in the Model 200. Control of the 4 auxiliary buses is delegated to this one panel using the 4 auxiliary delegate push buttons. At the bottom of Mix Effects 1 is the B background crosspoint row. Above that row is the A background row, and at the very top are the key buses which select sources for both Key 1 and Key 2. Sources are selected on the Model 200 by pressing the push button corresponding to the desired source. Our first source is internally generated black, which we have cabled to this input. The next source is Camera 1, our chroma key camera. Camera 2 is used as a background source, as is Videotape 1, Videotape 2, Still Store, and the Paint System. On inputs 8, 9, and 10 are 3 character generators. The associated key signals have been brought in on the external key source inputs and assigned in personality to follow the character generators input. We are not going to be using inputs 11 through 16 for this demonstration. Input 17 has color bars. Input 18 provides our test signal or ramp. On inputs 19 and 20, we have cabled internal background generators 1 and 2. Color is adjusted for the internal background generators at the matte control panel. We can assign this panel to any one of the 9. The luminance control is used to set the luminance of any of the 9 matte generators. In this case, it is assigned to background generator 2. Chroma sets the color saturation of the matte or background generator, and the hue control selects the color for the assigned matte or background generator. Each of the Model 200 background generators provides a unique feature called Background Wash. Background Wash allows users to wash either background generator from top to bottom or bottom to top. The Model 200 includes a powerful auto-delegation feature. Auto-delegation allows us to delegate the matte control panel between our two background generators, or any of the other 7 matte background generators. In this case, we have delegated it from background generator 2 to background generator 1. Now we can turn on the background wash for background generator 1 and adjust for the desired wash effect. Again, we have control of the hue, luminance, and chroma, separate from the other generators. Another feature is the ability to wash background generator 2 into background generator 1. This creates a full screen color wash. This is a feature of background generator 1 only. The key bus allows selection of any of the 20 primaries or 4 external fills as a key or fill source. This one row of push buttons can make selections for either key 1 or key 2 of this mix effects. This is done by auto-delegating the push buttons for the key buses between the 2 keyers. Note as we alternately push the key 1 and key 2 select buttons that the key bus row is changing to show the assigned source for each keyer. This is another example of how auto-delegation is used on the Model 200. Another unique feature of the Model 200 is the ability to accumulate the 4 external key fills with a primary source. In addition to selecting them individually, they can also be selected in any combination, up to all 4. And we can add to this accumulation by including any one of the 20 primary sources. This greatly expands the keying power. When we delegate from key 1 to key 2, the single bus changes to show the different key fill selection for each key bus. We'll discuss accumulative keying in more detail when we look at the mix effects keyers in a moment. The transition control area is used to effect changes between one effect setup and another. Transitions can be made by using the lever arm, cut, or auto transitions. As the lever arm is moved, an indicator illuminates to show the direction of the lever arm travel. One indicator for each direction. We can also make a transition using the cut or auto transition push buttons. The auto transition rate is indicated to the left of the auto transition push button. The currently assigned rate is indicated in frames. This rate can be changed very quickly in the eMemEffects memory control area. This is accomplished by pushing MixEffects 1 Transition Select, setting the rate on the 10 key panel, and pushing Enter. In this case, we are changing the rate to 45 frames. When an auto transition is initiated, it can be halted by simply hitting the auto transition button a second time. When this happens, the indicator light stays lit to indicate the direction of travel. When auto transition is initiated again, we conclude the transition. Alternately, we can conclude the transition using the lever arm. A transition can also be started using the lever arm and concluded using the auto transition, in which case both indicators light up when the auto transition concludes to denote that the lever arm is inactive until it is returned to either limit. This action does not affect the current effects output. It's in the transition control area where the decisions are made as to what the next effect will look like. This is done with the top 3 push buttons, background, key 1, and key 2. If background is chosen, the B background video will replace the current A background video with the next transition. If key 1 is selected, the next transition will bring in keyer 1, in this case the title graphic. If key 2 is selected, the next transition will bring in key 2, in this case the chroma key. These 3 push buttons can be selected, allowing us to change background, or key 1, or key 2 in any combination. To assist the operator in seeing what the next transition will look like, the Model 200 includes a look-ahead preview video output. The preview selector is found at the center of the upper panel area. As selections are made in the transition control area, they will appear on the preview monitor output. If just background is selected, we see the new background on preview. If key 1 is selected, we see the current background and key 1. If we select key 2, we see key 2 over the current background on preview. If background and key 2 are selected, preview shows the new background with key 2. Notice that the preview monitor changes instantaneously to show the new effect. Selecting all of the next transition push buttons allows users to change key 1, key 2, and the background simultaneously. As the lever arm is moved, note that the preview monitor immediately switches at the end of the transition to show us the next preset effect. When we select background and key 1, preview will show the new background with key 2. The next transition changes the background and key 1 is removed, leaving key 2. We will effect this change using the auto transition. Selecting background, key 1 and key 2 in combination removes key 2, adds key 1, and at the same time the background video changes. Again, the preview monitor shows the result of our next transition, and the effect is seen on the program monitor as the lever arm is moved. As an aid to the operator, the key on indicator shows when a key is active. In this case, key 1 is on, and as we begin a transition to key 2, the indicator comes on to show that key 2 is now contributing to the program output. At the conclusion of this transition, the indicator goes off, showing that key 1 is now inactive. Notice that the preview output also changes to reflect our next transition. There is also another indicator to show which key is over the other. We will discuss key over later on in the program when we address the key control area of the Model 200. Now let's take off key 2 and select background, which takes us back to our original video. Let's continue by selecting wipe in the transition mode rather than the mix mode. As in the mix mode, transition mode wipes can be executed using either the lever arm or auto transition. Another button in the transition control area is called Preset Black Mix. Preset Black will mix the program video to black with the first transition, and from black to our new effect with the next transition. We can use either the lever arm or auto transition to get the desired result. To assist in live operation, the Model 200 also includes a Trans Preview mode. When Trans Preview is activated, the preview output video will be the same as the program output. Transition will not affect the program output, but can be seen on preview. Transitions can then be rehearsed before putting them on the air. Turning off Transition Preview returns the switcher to normal. The basic wipe system provides 20 patterns selected in the first 5 columns of the pattern select. Let's begin our demonstration of the wipe system by selecting pattern 10, the curtain wipe. The wipe system is delegated to Mix Effects 1. The lever arm associated with Mix Effects 1 is used to wipe between backgrounds. Wipe direction push buttons determine the direction of travel for each wipe pattern. The Pattern Select push buttons provide a legend indicating not just the pattern, but the wipe direction as well. The white portion shows where the new video will occur when operating in the normal wipe direction mode. In normal mode, Pattern 10 travels from left to right as we do a 30-frame auto transition. When we select reverse mode, the wipe travels in the opposite direction, in this case exposing new video on the right side. The flip-flop mode works in conjunction with normal and reverse mode, causing the wipe system to alternate between normal and reverse wipe directions. Starting in reverse mode, wipe travel is from right to left with the first transition, and from left to right, normal direction, with the second transition. This can be altered by selecting normal mode while the flip-flop wipe direction is active. The next transition begins in the normal direction and returns in the reverse direction. The normal and reverse wipe direction lamps change each time the limit is reached when in the flip-flop wipe direction mode. Now let's add a border to the wipe by turning the border on and using the edge control to set the border width. Note that the border can be adjusted to approximately 80% of the screen, expanding from the center point of the wipe. The wipe border can be modified further by adding softness. This is done by turning on the Soft push button and then setting the amount of softness with the Softness control knob. The border can also be turned off, leaving only a soft edge with no border. The Edge Symmetry control, sometimes called the halo, allows the user to change the slope or softness of one edge independent of the other. At the counterclockwise limit, notice that the left edge is hard, while the right is soft. As we turn the control back in the clockwise direction, both edges soften, and then the right edge becomes hard, while the left remains soft. A continuous chirping sound indicates when the limit of a control knob has been reached. A single chirp indicates the middle of the control range. To demonstrate aspect and positioner control, Pattern 23 has been selected. When positioner normal is activated, the pattern jumps to the position last used. The pattern can be repositioned using the rate control joystick, both horizontally or vertically. The further the stick is pushed from its center position, the faster the pattern moves. If the pattern is out of view, the operator can easily bring it back to center screen by simply holding down the desired pattern select push button. When the size of a pattern is changed in positioner normal mode, the center of the pattern stays fixed as we make the transition. In auto center mode, the pattern moves smoothly toward the center of the raster as the size changes. When aspect is turned on, the aspect of the pattern can be modified horizontally or vertically. If the aspect control is adjusted in the clockwise direction, the pattern stretches horizontally. In the counterclockwise direction, the pattern again becomes a square, and then the pattern is stretched vertically. Note the chirping sound of the control as it's being adjusted. Returning the control to the midpoint, we again have a square. Another standard Model 200 modifier is pattern multipliers. These allow any of the 20 standard patterns or the enhanced analog patterns to be multiplied. These patterns can be multiplied up to 4 times, horizontally and/or vertically, providing over 300 possible pattern combinations. The Model 200 also has a powerful wipe memory feature. Operators can store up to 4 wipe pattern setups. To demonstrate this feature, let's store our current wipe pattern in User 3. Let's change this pattern using some of our modifiers, such as border width, softness, position, multipliers, aspect, or any other modifier in this wipe control area. All modifications to the original pattern are stored in User 4. Now, as we select our user wipes, the patterns that were programmed are recalled from memory, including all modifiers. The user wipe system will also save setups involving the enhanced analog and matrix wipe options that will be discussed next. When the enhanced analog wipe system is installed, column 6 of the pattern select becomes active. The enhanced analog wipe system consists of 4 additional patterns and new modifiers. This option includes a clock wipe, star, heart, and pointer wipe patterns. The enhanced analog wipe system activates this row of controls. The first modifier, split, allows us to split our wipe patterns. Using Rotate Select, we can step through the next 3 wipe modifiers. The first, angle, allows us to set the angle of the wipe pattern. Magnitude allows us to control the amount of rotation as a transition occurs. Speed allows us to set the speed of rotation. When one of these 3 modes is active, it is displayed to the left of the Rotate Select push button. The next modifier, pattern modulation, is activated with the Modulation Select push button. Sign modulation occurs on the horizontal axis. Frequency and amplitude can each be set with the knobs to the right of the Modulation Select push button. The modulation can be free-running or locked. This new set of modifiers apply to both the enhanced analog as well as the standard wipe patterns, such as the square, circle, or the curtain wipe. Any of the standard modifiers discussed in the previous section can be applied to the enhanced analog patterns as well. Now, let's turn the modifiers off and look at some of the special features of the clock wipe. Let's set the clock wipe up with a wedge-shaped border and a soft edge. Soft border symmetry also works on the clock wipe. The clock wipe is a rotary pattern which must transition a full 360 degrees to be completed. The rotate position control affects the clock wipe by allowing users to set the angle at which the clock wipe opens. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, or back to 12. Rotate angle and rotate speed have no effect on the clock wipe. Note that the pattern split is inactive when the clock pattern is selected. The pattern multipliers provide some interesting results when used with the clock pattern. The clock pattern can be positioned to create a searchlight wipe effect. Remember, any of the modifiers that come with the enhanced analog wipe option can also be used with any of the 20 standard wipe patterns, or can be used in conjunction with the 4 additional patterns provided with the enhanced analog wipe option. When the matrix wipe option is installed, columns 7 and 8 of the pattern select become active. These 8 push buttons provide access to 32 additional patterns. 6 of the push buttons have pre-assigned patterns, and matrix program push buttons 1 and 2 provide access to the remaining 26. Let's take a look at a number of wipe patterns available through the matrix wipe option. The matrix wipe pattern is assigned to matrix program push buttons 1 and 2, either with the diagnostic pod or Streamline Effects controller. Some of the standard and enhanced analog wipe modifiers we have discussed do not apply to the matrix patterns. These include the positioner, aspect, rotation, split, and multipliers. Border, softness, symmetry, and wipe direction can be used to modify the matrix wipes. A special feature of matrix wipes is pattern mix. The Modulation Select push button is used to choose pattern mix. Pattern mix allows the user to combine any analog pattern with a matrix pattern and is only active when the matrix wipe option is installed. In this case, curtain and the random pattern have been selected. The modulation amplitude control now becomes a pattern mix control, which determines the ratio between the two patterns. Any one of the 20 basic patterns or 4 enhanced analog wipe patterns can be combined with any one of the matrix wipes. We can now make transitions such as hearts, stars, circles, squares, or other analog pattern with a matrix wipe. As another example of pattern mix, we can use the Matrix Clock Wipe User Program 1 with the circle wipe to create a spiral waveform. This is just one of the many effects that can be created with this powerful modifier. Another feature of the pattern mix mode is the ability to bring in an external input and combine it with one of the analog patterns. The external input is assigned in personality to one of the matrix program push buttons, either with the diagnostic pod or the Streamline Effects controller. The source must be brought into the external mask wipe input. The amplitude pattern mix control allows the user to set the ratio between the external input and the analog wipe pattern. This feature allows us to paint a pattern on a paint system and then use it as a wipe. Let's use this clown's face to demonstrate transitioning between backgrounds. Using our external input, we see the image of the clown transition through the effect. Now, adjusting the pattern mix control, a combination of the curtain wipe and the external input is generating the wipe. As other patterns are selected, the effect changes. Modifiers can then be used to further enhance the effect. The key control area consists of the key cut push button. That allows us to cut the currently assigned keyer, in this case key 1, on or off the air. As the function is selected, the key on lamp lights to indicate that the key is on. It can easily be cut back to the off condition. The two buttons to the right delegate the key control area to either key 1 or key 2. The next row, Type, provides choices for luminance key, linear key, chroma key, and preset pattern. The clip and gain controls are located just to the right. Gain can also be used for preset pattern size when in preset pattern mode. Above the key types are the key fill and key source selections. The fill can be matte or key bus video. The key source can be key bus or auto select. When in auto select, system personality automatically chooses the key source. The key modifiers row provides key over, mask, key invert, and shadow controls. The density control is associated with the shadow modifier. The top row of push buttons control the linear borderline key edger option, which adds border, drop shadow, and outline to the key signal. To the right is the border luminance control. Next, let's look at the Model 200's luminance and linear keying operation. We'll begin by selecting Linear Key. Cutting the keyer on air, the key selector indicates we are operating on keyer 1. Our key fill will be the key bus selected here, which can be any of 20 primaries or 4 external fills. For key source, we have key bus selected, so our key source will also be our fill. This condition is called a self key. Clip and gain controls are used to set the key level. Adjusting the gain control clockwise gives us a high gain setting, which can then be adjusted with the clip control to set the best point for a proper key. When the gain control is turned counterclockwise, the key edge softens. For this example, we are using a test signal, linear ramp, which is now fully keyed when the clip control is rotated in a full counterclockwise direction. Now, let's select a more practical example, such as character generators on the external inputs. As mentioned previously, we can accumulate these externals in any combination. By selecting the matte fill mode, we can replace the key bus signal and use our internally generated matte signal as the fill. This condition makes the graphic easier to read because of the greater color contrast between the fill and the background. When selecting the matte fill mode, we automatically delegated the matte control area to the matte generator for this keyer. This is done automatically, with no additional operator action needed. Now the luminance, saturation, and the hue of the matte fill can be adjusted to the desired color. Notice at this time that we are keying from the video generated in the character generator rather than the key signal from that device. To utilize separate key signals, the Model 200 provides 6 inputs for each mix effects and 4 inputs for the downstream keyer. When Auto Select is enabled, the Model 200 derives its key source from a second bus in parallel with our key fill bus. In this case, we've chosen a key with a previously assigned personality. This graphic shows, in schematic form, the structure of the key source and key fill buses. Starting at the left are the 20 primary sources in a single cross-point row, which allows only one source to be selected. To the right, the bus branches, allowing the primary bus to feed the key bus and the fill bus. The 4 external fills have separate cross-points on the key and the fill buses, allowing them to be selected individually as a key or a fill. The 6 external key sources appear only on the key bus and are available for keying only, not as fills. Personality programming allows each of the primary and external key fills to call on one of the 6 external key sources to generate the key. These external keys can have multiple assignments. When a fill source does not have an associated external key source, self key can be assigned. In Auto Select, the Model 200 system automatically selects the assigned key signal when the key fill selection is made, freeing the operator from any additional action. Key invert allows us to invert the key. The matte signal is now filling the outside, while the background wash is filling the graphics. Mask allows us to inhibit or restrict where the key will appear. We will talk about masking in detail when we discuss chroma keying in the next section. In this example, we are using the mask to crop the key area. Key over determines which one of the 2 keyers in a mix effects will be over the other. Let's move up to the linear borderline key edger controls. This innovative option allows us to modify enhance keys for sources such as graphics by adding 1 or 2 line borders, 1, 2, or 4 line drop shadows, and 1 and 2 line outlines. Let's review the steps again. 1 and 2 line border, and 1, 2, or 4 line drop shadow, achieved with repeated pushes of the appropriate push button. 4 line drop shadow is accomplished by pushing the drop shadow button 3 times. Now the luminance of the drop shadow or border can be adjusted using the border luminance control. It should be noted that when in outline mode, this control is inactive. Now let's turn on the shadow modifier. When the shadow modifier is active, we can change the effect of the border and shadow modes, rather than generating an opaque or solid edge that is controlled by border luminance. We can now use the shadow control to set the amount of shading. The density control causes the fill video to be shaded, where our opaque border or drop shadow would otherwise occur. At the moment, we're using a matte fill. However, this could be any fill video. Another variation of the key edger is transparent shadow. To create this effect, select Edge Normal and turn on the shadow modifier. Now, shadow density controls the transparency of the shadow falling on the background video. When in the Edge Normal mode with the shadow modifier off, the linear borderline key edger option is inactive. This is a good place to review accumulative latching because it is most often used with luminance or linear key modes. Accumulative latching allows multiple sources to be combined in a single keyer. This can expand the keying power of the Model 200 or provide non-additive mix. The individual sources we'll use for this demonstration are the paint system with the word tape, character generator 1 with the word model, character generator 2 with the number 200, character generator 3 with the word operation, and title cam with the word the. By simply accumulating these inputs, we can combine up to 5 sources on either keyer of MixEffects 1. MixEffects 2 can use MixEffects 1 as a key fill or key source, allowing MixEffects 2 to accumulate up to 6 inputs. When sources are accumulated on a key bus, they create another desirable effect called non-additive mix, or NAM. To demonstrate NAM, we brought in a new source, a camera, into one of the external key fill inputs. We accumulated this with one of the primary sources, the clown. The accumulated video must be fully inserted to see the NAM effect. This is accomplished by turning the clip control to a full clockwise position. The result is a non-additive mix between the primary source and the external fill, accumulated on the key bus. With a NAM effect, the video with the higher luminance level will override the video with the lower luminance level. Thus, the white sky, the clown's face, and the yellow flowers appear in the foreground. To do a key breakaway, we first select our fill source on the key bus. Then, by holding down Auto Select, we can accumulate keys to create the composite effect. While the Auto Select button is held down, we select the key sources: Character Generator 1, Character Generator 2, and Title Cam. When we release Auto Select, we can see the fill source for the composite effect. The Model 200 incorporates a powerful feature called key memory. For each source on the key bus, a separate clip and gain setting can be memorized for luminance key, linear key, and chroma key modes. When switching to luminance key, we can observe an obvious change in the key. This is because of the different clip and gain settings. These settings can easily be changed. Another example of key memory involves selecting Test as our source. Note that we have one clip and gain setting for luminance key and a different clip and gain setting for linear key. At this point, we can also demonstrate the operating differences between luminance and linear key. The primary difference is that linear key has a lower gain range than that of the luminance key. In both luminance and linear key, a separate clip and gain setting can be memorized for each of 20 primaries and 4 external sources. To demonstrate chroma keying on the Model 200, let's use Key 2. When pushing Key 2 Select, we see that the key bus and the key control area is delegated to Keyer 2. Now we'll select Chroma Key mode. Our fill can be key bus or matte fill. However, our key source will always be auto-selected when in Chroma Key mode. Let's choose Camera 1, the frog and flowers in front of a blue screen, as our key source, and cut the Chroma Key on. Like linear key and luminance key, the clip and gain are automatically recalled when we make our key source selection. Now the hue control can be used to select the color on which we will key. As we rotate the hue, we key out the green of the frog, the yellow of the bird, and the red of the flowers, coming back again to the blue of our chroma key scene. Using the lever arm, we can change the background behind the chroma key. The modifiers in the chroma key mode work in much the same way as mentioned before. Masking prevents the frog's eyes from being keyed out. We chose the frog because of the difficulty in keying its eyes. We'll discuss masking in more detail in a moment. Key invert reverses the key polarity. Shadow provides a different facility when used in chroma key mode. It recreates the shadow cast on the background in the original chroma key scene and applies it electronically to the new background being inserted. The shadow density control sets the density of the shadow. A preset limit can be established for the chroma key shadow density. The limit is set by holding the chroma key push button down and adjusting the shadow density control. This feature is called chroma key shadow clip control. Except for the interaction with shadow density, the linear borderline key edger functions work the same in the chroma key mode as in the luminance and linear key mode. Now let's look at the mask control area. When mask is selected in key control, it's automatically delegated to the mask control area found in the upper corner of the Model 200 control panel. The mask control area consists of the following functions: key select, mask source select, mask invert, and forced foreground. Key select, which assigns the mask control area to any of the keyers and indicates this assignment to Key 1 Mix Effects 1, Key 2 Mix Effects 1, Key 1 Mix Effects 2, Key 2 Mix Effects 2, and the downstream keyer. Mask Source Select determines whether the currently assigned keyer will be masked with its own dedicated shutter mask, the wipe generator in Mix Effects 1, the wipe generator in Mix Effects 2, or an external mask input. There are 5 shutter masks in the Model 200, one for each of the 5 keyers. Model 200 mask functions also include mask invert and forced foreground mode. The shutter mask has a control for top, left, right, and bottom. When using one of the wipe patterns, the bottom control sets the size, and the top control sets the softness of the mask edge. Let's look at some examples of each of the mask types. While in the chroma key mode, let's turn on the mask modifier. The shutter mask limits the chroma key area. We can control the left, right, top, and bottom sides of the mask. As an aid, the preview channel dims automatically to make it easier to locate the mask. Notice that the frog's eyes are filled with the background video. This is due to the way the frog was lit and the way in which the keyer was adjusted. We can correct this problem using a mask. The eyes of the frog are framed in the shutter mask, but rather than forcing the eyes through the foreground, we can force the background video. By enabling forced foreground in the area of the mask, we can now force the foreground video in the mask area rather than forcing the background video. Note that there is some blue foreground video showing through because the shutter mask is unable to follow the irregular shape of the frog's head. Let's use a white pattern as a mask to try to correct this problem. Pressing Mask Source Select will step from Shutter Mask to Mix Effects White Mask. We'll use Mix Effects 1 in this example. In the white control area currently delegated to Mix Effects 1, we'll select an appropriate white pattern. In this case, we've chosen the circle wipe as the mask pattern. Position the wipe around the frog's head, changing the aspect to try to accommodate the shape. Now we can set the mask size using the bottom control of the shutter. The top control of the shutter mask softens the mask. It's obvious that the polarity is not correct because the chroma key is being masked on the outside rather than the inside of the circle. Mask invert is used to reverse polarity. Any of the standard wipes, including the enhanced analog or matrix wipes, can be used as masks. The mask edge cannot be bordered but can be softened. Note, too, that the lever arm does not affect the mask size. Review the wipe system segment of this program for a detailed explanation of wipe modifier applications. Obviously, the circle wipe pattern we selected to mask the frog's eyes isn't working, so let's use an external mask. To select an external mask, use Mask Source Select. In this case, we have already created the mask input using the Dubner DPS-1 paint system. The mask is simply a black and white signal with two white dots corresponding to the frog's eyes. The effect of the mask is seen by simply turning the mask on and off. External mask is brought into the mask wipe input on the electronics frame of the Model 200. Let's look at the key over function of the Model 200. We'll begin by bringing in a chroma key using key 2. Then we'll bring in a graphic using key 1. See how the graphic in key 1 appears over the chroma key of key 2? Now we'll use the key over function to change the priority of the keyers. As this occurs, the over indicator changes in the transition area. This allows us to determine the priority of the two keyers in a particular mix effect setup. To demonstrate preset pattern operation on the Model 200, let's first select Preset Pattern on Keyer 2 of Mix Effects 1 and mix it on air. For this example, let's use the circle wipe pattern. All the wipe modifiers are active, such as positioner, aspect, softness, border, and so forth. The size of the preset pattern, however, is adjusted in the key area by the Gain Preset Pattern Size control, rather than with the lever arm. Preset pattern fill, as with the other key modes, comes from either the key bus or the color matte generator. Key source select has no effect in preset pattern. We can change backgrounds behind preset patterns just as if they were keys. In preset pattern, the shadow control has yet another mode of operation. When activated, shadow attenuates or dims the entire field outside the preset pattern. When we bring up the same background video which is filling the preset area, we create a spotlight effect. We can now adjust the density control and modify the spotlight effect being created. Key invert and mask have no effect in preset pattern mode. The downstream keyer is located at the lower right-hand side of the Model 200. This keyer is used after or downstream of the mix effects and is the last keyer before the program output. The downstream keyer is sometimes referred to as the DSK. The DSK background selection determines whether Mix Effects 1 or Mix Effects 2 will appear behind the downstream key. The transition area operates like the Mix Effects transition areas, allowing background, key, or both to be changed. Transitions are made using the Auto Transition or Cut buttons. Like the Effects area, the Auto Transition rate is shown in frames, directly above the Auto Transition button. The DSK provides luminance and linear key, but not preset pattern or chroma key. The key fill and source controls operate like the Mix Effects controls. Mask, key invert, and shadow modifiers provide the same capabilities discussed in the Mix Effects. The DSK key bus allows us to select 4 external fills: Mix Effects 1, Mix Effects 2, and Auxiliary Bus 1 as key fill sources. These sources can be accumulatively latched in any combination. The key sources can be external or self-keys as determined by personality programming. There are 4 external key sources in the DSK. Program Fade to Black is also provided in the DSK control area. This allows us to fade the program output to black at a rate programmed in frames, or to simply cut the output to black. There are 3 basic elements to this example. One is the background wash, and the 2 others are the 2 keys selected in Mix Effects 1. Let's remove the glow which is being added with the key in Key 2 and look at just Key 1. Key 1 consists of a linear key with a matte fill, 4-line drop shadow, and the shadow modifier to shade the edge. We are keying from Character Generator 1, Character Generator 2, and the title cam accumulated together to create the composite graphic. Let's take Keyer 1 out, bring Keyer 2 back in, and see how the glow effect was created. Key 2 is the same as Key 1 except for the mask. The movement of the glow effect is a Mix Effect 1 white pattern, masking Key 2. We are also matte filling as we did with Key 1, but our matte is a brighter color than Key 1. Bringing Key 1 back in, we can see the composite effect. Again, the background itself is a wash created in the Model 200. This concludes the videotape presentation of the Model 200 operator's demonstration. If there are still questions concerning this exciting new product, it might be beneficial to view certain program segments again. The segments have been indexed for your convenience. The Grass Valley Group is happy to solicit your questions and comments. This program is an overview of the operation of the standard EMEM effects memory system and the optional Streamline Effects Controller and Disk Storage System, which is part of the Grass Valley Group Model 200 production switchers. This is the second videotape in this introductory series on Model 200 operations. It would be helpful for the first-time viewer of this program to review the first operations tape in this series to get a better idea about the overall operating philosophy of the switchers. This first show is entitled Model 200 Operations and can be obtained from any local sales office or distributor of Grass Valley Group products. Now let's begin. Note that EMEM effects memory and Streamline effects controller functions are accessed in the upper left-hand portion of this Model 200-2 control panel. EMEM effects memory can be defined simply as a way of taking a snapshot of the effect setup of the Model 200 switcher panel for later recall. In other words, EMEM will learn every push-button position, every analog control, all transition rates between sources, and it gives the operator a single push-button recall of a desired setup. The EMEM effects memory system is standard in the Model 200 and can learn and recall up to 30 different effect setups. Streamline enhances the EMEM effects memory system by adding powerful attributes and tools, which will be described in detail as this program continues. Before examining the Streamline option, let's take a close look at the operation of the EMEM effects memory system. The EMEM panel is made up of the display window, keypad, learn push buttons, recall push buttons, and transition rate push buttons. EMEM effects memory can memorize and recall setups of the entire switcher or selected areas. EMEM doesn't move anything physically on the control panel, but merely remembers the electrical values of the different effect setups. The system has separate learn and recall push buttons for the four major switcher areas: Mix Effects 1, Mix Effects 2, downstream keyers together with background generators, and the user program area. It also has Learn All and Recall All push buttons, which enable the effects memory to learn or recall the entire effect at once. Notice that this system is recall-oriented. Whenever a Learn push button is selected, the corresponding Recall push button lights to remind the operator which level they're working on. The Recall push buttons remain on after the learn is complete, allowing an operator to perform an immediate recall simply by pressing one of the register numbers on the keypad. These memory registers are arranged in banks of 10 registers, numbered 0 through 9. The standard effects memory system contains 3 banks, numbered 0, 1, and 2. If Streamline is part of the system, banks 3 and 4 are also active. Register numbers are written in the display as a 2-digit number with the bank number on the left and the actual register number to the right. Pressing bank in the keypad repeatedly selects each of the memory banks in turn, with the current bank indicated by the digit to the left. Each register has 4 levels, one for each switcher area. This means it's possible to store effects into each level, separately or in any combination. For example, Mix Effects 1 and Mix Effects 2 could be stored into register 20 during one learn operation, and later user program could be stored into register 20 during a different learn operation without affecting the Mix Effects 1 and Mix Effects 2 levels. In addition to the bank push button, the keypad area is made up of numerical push buttons 0 through 9 and the Enter button. The 4 transition rate selector buttons and the last X clear push button are located at the bottom of the EMEM panel. The transition rate selector buttons are used to enter auto transition rates for Mix Effects 1, Mix Effects 2, downstream keyer, and fade to black. The last X clear push button has 2 separate functions. If the Model 200 is in a recall state, which means no Learn or Set Trans push buttons have been selected, pressing Last X Clear will return the switcher to the state prior to the last recall. This is helpful if you fail to enable the Learn push button after using the keypad for a specific effect setup. The second function of Last X Clear involves the Set Trans push buttons. If any Set Trans push button is selected, pressing Last X Clear sets the EMEM display to 0 frame rate. That's basically all you need to know to benefit from this innovative feature. Now that we have a better operational understanding of the Model 200 production switcher's EMEM effects memory system, let's continue this program by exploring the operation of the Streamline effects controller and disk storage system, and examine how this powerful option works to enhance the creative possibilities of the effects memory system. Streamline is menu controlled and not only extends the usefulness of EMEM, but also introduces its own new effects and operations. For those operators who are not familiar with treed menu-controlled devices, this operational design makes it possible to incorporate control of many more functions in a smaller space on the switcher panel. The operator selects a specific function from a top menu and steps down to the next level, which accesses new features or functions. All Streamline functions follow this same basic operating logic. The Streamline Effects controller panel consists of a display, 6 associated push buttons, a control knob, and a disk drive for offline storage of effects and personality data. Notice that the display shows 2 lines of alphanumeric characters. It is used to display data or prompts for the various Streamline operations. The top line of the display generally shows data related to the function selected, and the bottom line is used to display the selections available under the menus and to relabel the 5 soft push buttons under the display. The soft push buttons are then used to make a selection from the menu or to perform the selected function. The 6th push button, Exit Home, is used to return to the previous menu or go directly to the top-level Home menu. Holding down Exit Home for half a second returns the display directly to the top level or Home menu. The soft push button labeled More, found in some menus including the Home menu, toggles the display to show additional menu selections available from the current menu level. There are 8 home or top-level selections that will be highlighted in this program. Register attributes, which modify an EMEM register to change its behavior on recall. Timeline, which is basically a programmed series or sequence of events such as auto transitions, effects recalls, or general-purpose interface triggers. Keyframes, which lets an operator build up a sequence of up to 15 effects. Offline disk storage, for storage of effects memory and personality data on removable disks. Selecting the More push button takes us to Personality Programming, which lets users customize some Model 200 production switcher operations to the needs of their own facility. Lock, which locks registers individually or as banks against learns. ME Copy can copy a control panel setup from one ME to the other. And Miscellaneous, used to enable different peripheral devices and GPIs. As you step down through any of these top menus, you get a better idea of the power behind the Streamline Effects controller. Now let's explore several of these top-level menus in more detail, using specific examples beginning with Attributes. To access the register attributes, select Attribute from the Home menu. The next level down reveals the assignments possible using this menu. Register attributes can be learned into effects memory registers in 3 steps. First, the bank and register are selected from the effects memory keypad. Next, the appropriate switcher area is selected from the Streamline menu. And last, the desired register attributes are programmed. The attribute programming display will differ depending on the switcher area selected. Mix Effects 1, Mix Effects 2, Downstream Keyer, or User Level. Note that the area selected is identified in the upper right-hand corner of each programming display. To program an attribute into a selected register and area, the push button below the attribute name is pressed. Names of the attributes available to selected parts of the switcher are abbreviated in the bottom line of the display and include Effects Dissolve, Auto Transition Trigger, Crosspoint Disable, which disables recall of background crosspoints, and General Purpose Interface Output, also known as GPI output or Peripheral Bus GPI triggers. These cause relay closures or peripheral triggers to be transferred. All of the attribute programming push buttons, except for GPI, operate by alternately selecting and deselecting the attribute. Pressing a push button once changes the state. When the attribute is selected, a symbol representing that attribute appears in the top part of the display. Going up one menu level, the Attribute Register Area Selection menu shows the attribute status of the entire register at once. All 4 switcher areas are displayed. When a register with a stored attribute is recalled, the corresponding function will be triggered. Note that GPI and Peripheral Bus GPI triggers will take effect only if the Enable push buttons located near the top of the Model 200 are lit. Now let's integrate all this information about attributes by demonstrating a few production examples of this powerful Streamline Effects controller.
This part of the show is designed to help you program 3 different Streamline functions using the Attributes menu that will make your job as a Model 200 operator much easier. First, we'll show you how simple it is to do an effects dissolve between 2 effects memory registers. Then demonstrate an auto transition in a sequence of register recalls, and last, how to clone or copy attributes. Watch the program output of the Model 200, inserted at this point on the screen, to help you understand more clearly the results of this attributes demonstration. Looking at our first example, we'll do the effects dissolve between register 8 and 9 in Bank 0. We begin by calling up the Attribute Register Area Selection menu. Then we'll recall register 8 and program an effects dissolve for that register. Next, we'll clear Auto Trans, GPI, and No Crosspoint if they've been set. Now we follow the same sequence for register 9. Recalling this setup, we can see the effects dissolve between registers 8 and 9. For our second example, we'll use registers 1, 2, 3, and 4 in Bank 0. Now move to the Area Selection menu and choose Mix Effects 2 Area, and select Register 1 on the EMEM panel. While in the Attributes Programming display, turn on Auto Transition. Select Register 2 and turn on Auto Transition. Repeat this operation for registers 3 and 4. Now as we step through registers 1 through 4, the recall occurs and includes an auto transition trigger. That's all you need to do to program an auto transition in a sequence of register recalls. The last example we'll show you is the cloning of an attribute. Whenever we do a learn while in the Attributes Programming menu, the currently established attributes are cloned or memorized along with the rest of the effect. To demonstrate this, we will store this effect in Bank 0, Register 5, and this effect into Register 6, When these registers are recalled, the auto transition trigger previously enabled has been saved in these registers. Now let's continue this program by examining the other home menus in the Model 200 Streamline Effects controller.
The next function on the top-level Home menu is Timeline. Timeline is a programmed series of events such as register recalls. The Streamline Effects controller has the capacity to learn 10 different timelines into 10 separate effects memory registers located in Bank 4. There is also a working register used when constructing and/or editing a timeline. Each timeline can be up to 10 minutes long. Time is broken down into minutes, seconds, frames, and fields. When a timeline is being programmed, a timekeeper in the upper left-hand corner of the display shows the time or position on the timeline. Any single field can hold up to 5 events, with as many as 50 events per timeline. It's important to note that a timeline only programs starting times for events. Subsequent events may truncate or terminate a previous event if adequate time between events is not programmed. 4 different kinds of events can be programmed onto a timeline: auto transitions, holds, effect memory recalls, and GPI and peripheral GPI triggers. When a timeline is running and comes to a programmed auto transition, the result is the same as pressing the corresponding auto trans push button. A hold is a command to stop the timeline until a transition has been performed in a designated area of the switcher. Hold is broken when an auto trans, cut, or lever arm transition is made. A timeline can be programmed to recall any eMem effects memory register in any of the 5 banks. 6 hardwired GPIs and 6 software peripheral GPI triggers can be accessed through the Streamline Effects controller. Now let's look more closely at the Timeline main menu. The Timeline top-level menu contains 4 possible choices: New, Memory, Edit, and Run mode. New is used to create a new timeline. Pressing this push button clears the working register and calls up the Timeline Edit menu. Edit is used to edit a timeline created earlier and stored in the working register. Pressing Edit takes us down to the same menu level as New, but does not clear the working register. The timeline itself is shown as a dashed line in the upper right-hand part of the display, with events programmed along it. Turning this control knob moves the timeline along. As the knob is turned, the timekeeper shows the current location in the timeline by minute, second, frame, and field. Slow Fast lets the operator choose the sensitivity of the control knob when you are in the time mode. Time Event can be used to select one of 2 ways to move through the timeline. As the knob is turned, the entire timeline can be scanned field by field in the time mode, or only those times which have events already programmed into them can be scanned in the event mode. Arrows appear at either end of the timeline to indicate which direction the programmed events are located. Use Time mode to select a particular point in time by turning the control knob. Use Event mode to move quickly from one programmed event to the next. Skipping over the pointer symbol for the moment, let's look at Step. Step runs the timeline 1 step at a time. Step operation is modified differently for the Time Event mode. In the Event mode, the first time that Step is pressed, the Step mode is turned on, and the display moves to the first event in the timeline. But notice that no event is performed. The next time that Step is pressed, the selected event on the timeline, which is in brackets, will be performed, and the brackets will move forward to indicate the next event in order. Operators can use the control knob to back up to an event and resume stepping from there. Note that turning the knob does not cause any events to occur. In the time mode, pressing step the first time will take timeline back to the beginning for a new start. All events in a field are bracketed together, and all of them will be performed in order. If one or more of the events is a hold, step will perform all the preceding events and then wait for the operator to perform the required transitions. If the operator chooses to use the control knob in the time mode, the timekeeper will change to indicate the new position in time. However, the next time step is pressed, the timeline will return to the first events programmed. The next function in the timeline edit menu is non-drop frame or drop frame. If the non-drop mode is chosen, the timekeeper will count every field in order. If drop frame mode is chosen, 4 fields are dropped from the count each minute in order to match timekeeper time to standard clock time. Timeline operation is not affected, only the timekeeper indication changes. Now let's skip back to the pointer symbol on the timeline edit menu, which serves as an entree to the programming menu. The timeline programming menu allows the operator to delete, add, or move events on the timeline. Delete removes bracketed events from the timeline. Insert will take you to the next menu, where event types are selected. If other events are already programmed at that time, then the new event will be inserted immediately in front of the bracketed events. After Insert is pressed, a new display appears, offering 4 types of events for insertion: Autotrans, Hold, Recall, and GPI. When one of these types of events is selected, another menu appears, allowing an event to be programmed onto the timeline. Transitions and holds are programmed onto the timeline as soon as the area to be held or transitioned is selected. Recalls and GPIs are put on the timeline when Confirm is pressed after selecting the event. Append works similar to Insert, except that the appended event will be added immediately following any bracketed events in that field. Undelete appears as a menu choice only if a delete has been performed. Pressing Undelete restores the deleted event. The undeletable as long as the timeline has not been edited or trimmed since the delete was performed. The last function on the timeline programming menu is Trim. Trim allows an operator to move bracketed events in the display in either direction on the timeline. The timekeeper indicates which field contains the bracketed event. And turning the control knob selects the amount of time, plus or minus, that needs to be trimmed from the event. Note that events cannot be trimmed past other events on the timeline. After pressing Confirm, the display will show the event in the new position on the timeline, which is the original field plus or minus the trim time. Now let's move back up to the timeline top-level menu and look at Memory. The Memory function allows the retrieval of a stored timeline previously saved in a bank register and puts it into the working register. The upper left-hand side of the display indicates the currently selected timeline register. To select a different register, the Register Up and Register Down push buttons are used. When the desired register number appears in the display, the Retrieve push button is pressed. The message Copied to Work Register indicates the retrieval has been performed. If the message continues to say "No copy performed," it means that there is no timeline stored in the selected register. Timelines are stored using the Effects Memory Control Panel. The sequence is: select Bank 4, press Learn All, and press a register push button. And in the working register will be stored into the selected effects memory register. Timelines are recalled by selecting Bank 4 and Recall All, then pressing the desired register push button. The timeline stored in that register will run from its beginning. The final function on the timeline top-level menu is the Run mode. The Run mode allows an operator to run or step on the timeline currently in the working register. The Run mode display indicates that there is the option of running the timeline all at once or stepping through each programmed field, one step at a time. The status message in the upper left-hand corner indicates the current state of the Run mode. Pressing the Run push button starts the working register timeline running from the beginning with the appropriate indication in the message display. The timeline will continue to run the programmed events in order and will stop only when a programmed hold is encountered, or the Halt push button, or the last X push button in the effects memory register is pressed, or at completion. If a hold is encountered, a status message will appear in the top line of the display to show which switcher area is affected. Last X will also stop a timeline when recalled from an effects memory register. Step is the next function in the Run mode display. Pressing Step the first time turns the step mode on. Pressing Step again performs the current event on the timeline. The timeline advances to the next field containing an event or events and waits there until the Step push button is pressed again. Step can also be canceled by pressing Halt or Last X clear. Note that holds require special attention when stepping through a timeline because an operator must manually perform a transition before proceeding. The last function on the Run mode display is Halt. We've already discovered that Halt stops a timeline in progress or cancels the step mode. Note that when Halt is pressed, the status message returns to idle. This concludes a general overview of the versatile timeline function of the Model 200. Let's take this newfound knowledge and apply it to some specific examples to show how timeline might be applied in a production environment.
For our timeline example, let's create an effects sequence and put it on the timeline. For our sequence, we'll recall an effect from Register 1, then mix in a key on Mix Effects 2. Now we'll recall our next setup, then wipe to a new background. Recall the next setup. Mix in a second key. Recall our last setup, and wipe out both keys and the current background. All of these effects have been stored in Bank 0. Now let's begin programming the recalls at 2 seconds apart. First, we'll select Timeline from the Home menu, then New, which takes us to the Edit menu where Time mode is selected. The first event will be programmed at 0 minutes, seconds, and frames. Selecting the pointer takes us to Insert, then Recall. On the EMEM panel, select Recall All, Register 1. Now push Confirm. Now we can use the control knob to move the timeline forward 2 seconds and continue to program the remaining registers 2 seconds apart. Auto transitions are added following each recall by using the event mode rather than the time mode so that we can go directly to each event. By having auto transitions on the timeline instead of using the attributes function, we can trim the recalls and the auto transitions independently. Rather than using the insert function, let's use the append routine so each transition occurs after the recall. Use this sequence. First, exit to Timeline. Press Edit to reach the Edit menu. Select the Event mode and then hit the pointer. Rotate the control knob counterclockwise to go back to the first event to append the transition in the Mix Effects 2 area. Now the auto transition can be programmed following the register recall. Both the recall and the auto transition will happen at 0 minutes, seconds, and frames on the timeline. Turning the control knob clockwise advances the system to the next event at 2 seconds on the timeline, where the transition is appended on Mix Effects 2. This process is repeated for the remaining events. For additional effect, let's end the sequence that's just been created with a fade to black at 10 seconds on the timeline. Again, exit to the Timeline menu. Switch to Time mode. Push the pointer to reach the Edit menu. Insert a transition for fade to black. Exit and run.
The third home-level menu we'll explore is keyframes. Keyframe functions allow an operator to construct a sequence of 15 different switcher setups and then select the manner and rate in which analog values are dissolved from one keyframe to the next. Digital functions change immediately at each keyframe. Like Timeline, there are 10 separate registers available for keyframe storage and a work file. Keyframes are stored in Bank 3. Keyframes are useful for special visual effects and moving or traveling masks. Keyframes act upon all analog variables. These variables are divided into 2 types. Spatial, having to do with size, aspect, and position, and non-spatial, having to do with such things as color, border size, and soft symmetry. The values that are spatial can be changed as a spline, a dissolve, or an S-curve. The values that are non-spatial are always dissolved. That is, one value changes to the next in a straight linear fashion. The Keyframe Enter menu allows an operator to enter switcher setups into the keyframe working register. All possible keyframe numbers, 0 through 14, are shown at the top line of the display, above a pointer symbol, which points to the selected keyframe. If there are existing keyframes, the selection can be changed by pressing Shift Forward on the left or Shift Back on the right. When the correct keyframe number has been selected, the desired effect can be set up on the switcher control panel. Preset pattern keys, or key mask, are used most often for keyframe effects. Enter is pressed to store the setup in the working register. All following keyframes will automatically shift to a higher number. The keyframe menu can also be used to monitor the keyframe sequence currently in the work register. The Shift push button is used to move through the keyframes. The keyframe sequence can be edited by pressing the push button below the pointer symbol to get to the keyframe function menu. This menu lets an operator create, edit, and run keyframe sequences. Pressing New clears the working register and allows the construction of a new keyframe sequence. Edit goes to the Edit menu so that keyframes can be added or deleted. Run will run the keyframe sequence in the working register. One or more recall push buttons must be selected to have it operate. Bank 3 will be selected automatically. Pressing Memory takes us to the Memory menu so that keyframe sequences can be retrieved. Pressing More takes us to the Type and Times functions. Pressing the Type push button cycles through the three choices mentioned earlier: Spline, Dissolve, and S-curve. Spline is the default type. When it is selected, the keyframe edge effects change according to a best fit curve instead of in a linear fashion. Dissolve produces a linear dissolve, or path of constant velocity between two keyframes. S-curve moves through space in a straight line like a dissolve, but accelerates at the beginning and decelerates at the end of each keyframe. Note the current choice is shown in the upper right-hand corner of the display. Pressing the Times push button takes us to the Time menu, where sequence time can be adjusted in one of three ways. Time effect changes the total length of time and sets all keyframes to the same length. Time keyframe lets an operator change the time of an individual keyframe. Time delta makes changes so that all keyframes are adjusted in the same proportion as a percentage. Back up to the keyframe function menu and note the indications at the top of the display. Time shows the total time in seconds and frames required to run the keyframe sequence. Keyframe shows which keyframe is currently selected. Tension refers to the amount of curve in a spline. The range is 0 to 100%. 100% is a straight line, and 0% is the maximum curve. The Effects Memory Control panel is used to store a keyframe sequence. This is done by selecting Bank 3, pressing Learn All, and then pressing the desired register push button. The keyframe sequence in the working register will be stored into the selected effects memory register. A previously stored keyframe sequence is recalled by selecting Bank 3, pressing Recall All, then pressing the desired register push button. The keyframe sequence stored in that register will run from its beginning. Now let's turn our attention to programming some specific streamlined keyframe examples that might be applicable in a typical production environment.
For this keyframes example, let's key one of the mix effects in the preset pattern mode with the shadow modifier to create a spotlight effect. This effect will be used to follow the airplane in a sequence that was shown earlier in this section. EMEM effects memory registers have been used to store a series of positions and sizes for the spotlight. These are recalled and then inserted into the keyframe. This was done by jogging the video forward, noting the timecode where each effect was saved in EMEM. Then the registers were used to create the keyframe effect. The time between each keyframe was edited. Let's watch the results of this effort again. Now let's show you step by step how it was created. The sequence is: exit to keyframe menu, select pointer, select new, recall bank 1, register 1, press enter. Recall the previously created EMEM registers and insert them into the keyframes sequentially. Select the pointer and press Run. To program the duration of the keyframes, select the pointer again. Press More. Select Times, then Time Keyframe, and program the duration of each keyframe. Hit Exit. Select Pointer and run this keyframe example.
The next home-level menu selection is disk storage. 4 different types of data can be saved on the streamlined disk storage system: personality programming, effects memory registers, user wipes, and matrix patterns. Note that disk operations do not shut out other switcher functions. That is, an operator can exit the disk menus and use other areas of the switcher while a disk operation is in progress. The top-level disk menu has a place in the upper left-hand corner to name the disk. The name of the file last entered is shown in the upper center. The type of file is shown in the right-hand corner. Menu selections are Directory, which shows the names and types of files on the disk; Retrieve, which is used to retrieve saved data from the disk into the switcher; Save, which is used to save data from the switcher onto the disk; Copy, allows an operator to copy an entire disk, copy files from one disk to another, or to make a duplicate of a file on the same disk. Delete, removes unwanted files from the disk. And Utility, permits formatting or checking what's available on a disk. Because the operation of disk storage is so straightforward, it's recommended that the operator refer to the Model 200 Production Switcher Operator's Handbook for details on how to use this streamlined feature. This will allow us more time to concentrate on other streamlined functions like the next home menu, Personality Programming, found by pressing More. Personality programming lets a user customize their Model 200 production switcher to their own particular configuration. Parameters that can be programmed are grouped together in levels, organized under 6 different menu headings. Keyers, Enables, Matrix, GPI in, Restore, and Version. Let's go back up to the Keyers menu level, and moving down a level, we see the Key Source Assignments. Before explaining key source assignments in detail, it's important to remember that the Model 200 production switcher is fill-oriented. The key sources can be assigned to follow the fills automatically. In auto-select mode, the key source will be whatever external key input has been assigned to the fill input currently selected on the key bus. Key source assignments are available for Mix Effects 1, Mix Effects 2, and pressing More for the downstream keyer. After making a selection, a key source assignment menu will appear in the display. The upper left-hand corner will identify the keyer chosen and the key bus crosspoint currently selected for assignment. Crosspoint selections are changed by pressing Next or Previous. The crosspoint part of the display will cycle through the key bus crosspoints. Crosspoints can also be selected by pressing the corresponding push button on the Mix Effects key bus. When the appropriate crosspoint to be programmed is displayed, observe the source equal indication in the upper right-hand corner. It will show the current key source assignment. The assignment can be changed by pressing up or down. The source equal indication will cycle through self-key or external keys 1 through 6. Source assignment takes place as source selection is changed. The next keyer function we'll look at is Copy. Copy lets the operator copy key source assignments from one Mix Effects keyer to the other Mix Effects keyer. From and to are pressed until the copy statement shows the correct keyers as the source and destination. The key source assignments made on the source keyer are automatically copied to the destination keyer by pressing Copy. The Filters function controls the subcarrier filters on the key processing circuitry. 3 modes are possible. In auto mode, self keys will be filtered, but not external keys. When the subcarrier filters are off, the filters are disabled for all keys. In the on position, external keys and self keys will all be filtered. Modes can be selected independently for each of the 5 keyers. A chroma keyer is an option which contains 4 chroma keyers. 1 or 2 of the options can be installed in the Model 200. To make chroma keyer assignments, a chroma keyer must be assigned to the key bus input used for the key. This chroma keyer will then be used as the key source. The chroma keyer assignment menu indicates chroma key in the upper left-hand corner of the display, and the crosspoint currently selected for assignment. The crosspoint selection is changed by pressing Next or Previous, or by pressing the corresponding push buttons on the Mix Effects key bus. The crosspoint equals part of the display will cycle through the available crosspoints. When the desired crosspoint is displayed, the source equal display will show the current chroma keyer assignment. The chroma key source assignment can be changed by pressing up or down. Source assignment takes place as soon as the source selection is changed in the display. The last function in the Keyers menu is concerned with linear key clip and gain default settings. This function allows a default clip and gain setting to be programmed for the linear key push button in each keyer. Default values are recalled by holding down the linear key push button for 1/2 second. This default is independent of key memory. Now let's move back up to the Personality Programming menu and press Enables. This new menu includes on-off functions for the downstream key auto drop, beeper, super black, PAL limiting, blanking, and key memory. The downstream key auto drop function automatically takes a downstream key off air when a background crosspoint button is pressed on the on-air bus feeding the downstream keyer. The Enables menu beeper function allows an operator to turn the sound that certain panel controls make either on or off. The beeper indicates the electronic limit of the analog control knobs by chirping repeatedly whenever a knob is turned to a limit. The next Enables function from the Personality Programming menu is Super Black. The keyers in the Model 200 switcher have enough range to key from an input containing Super Black at blanking level. If the switcher being used is set for either NTSC or PAL-M standard, Super Black matte signals can also be generated in Background Generator 1. The PAL limiting function can be turned off, but the resulting colors may violate television standards in some areas. The blanking function will normally be left on. Blanking inserts an internally generated blanking interval and burst into the program output video so that sync and burst levels are consistent throughout the system. Blanking can be turned off to make it easier to time the switcher. With blanking off, sync and burst levels of the individual inputs will be passed through the switcher. Key memory is the last function of the Enables menu. If key memory is on, clip and gain values will be stored automatically whenever a luminance, linear, or chroma key is set up. The values are stored separately for each type of key and for each key fill input. These clip and gain values are automatically recalled when the same key fill input is selected. Going back up to the top of the Personality menu, let's look at Matrix. The top line of the Matrix menu display shows the current assignment of both Matrix push buttons. The Matrix 1 push button is programmed by pressing the push buttons on the lower left part of the display, either up or down. The Matrix 1 assignments will cycle through external mask pattern input and the 26 pre-programmed matrix wipe patterns. Individual patterns can be seen in this mode by monitoring the output as the pattern assignments are changed. Matrix 2 is programmed in a similar way, using the up and down push buttons in the middle of the display. Now let's leave the Matrix menu and move to the next Personality Programming function, GPI inputs. The Model 200 system provides 8 GPI inputs. 4 of these are dedicated to the 4 auto transition functions. When a GPI input is activated, the result is exactly the same as pushing the corresponding auto trans push button. The other 4 inputs can be assigned to control EMEM registers 0 through 9, certain downstream keyer functions, and cut push buttons on the control panel. The last Personality Programming function is Restore. This function resets current switcher personality to a default state. The default personality will have been previously programmed when the system was installed. Default personality can only be programmed at the electronics frame and not from the control panel. When using the Streamline Effects Controller, operators only change the current personality. The Streamline Data Storage System can be used to save current personality if needed. Now, let's conclude our program by looking at the last home-level menus in the Streamline system. Lock protection allows operators to lock effects memory registers individually or bank by bank against new learns to protect them against accidental loss. Mix Effects Copy can control panel setups from one Mix Effects bank to the other, or exchange settings between two Mix Effects banks. Copy functions are very useful if an effect has been set up on Mix Effects 2 and then it is decided that this setup would be better as a re-entry into another Mix Effect. The setup can easily be copied to Mix Effects 1 since Mix Effects 1 can be re-entered into Mix Effects 2. Copying is also useful if a duplicate of a key setup is desired. The last home menu in the Streamline system is Miscellaneous. Miscellaneous allows the Model 200 production switcher to control peripheral devices from the switcher's control panel. Using a special peripheral interface, users can interconnect the switcher with devices such as Kaleidoscope DPM1, Dubner character generators, Horizon routers, and many others. Operation of the peripheral devices is integrated into the effects memory system and can be activated using eMem register learns and recalls, or timeline. Obviously, the Streamline Effects Controller and Disk Storage System, when combined with the eMem Effects memory, adds new creative power to your Model 200 production switcher. This program was produced to demonstrate operational highlights of the effects memory and optional Streamline system. If there are still questions regarding specific use, please refer to the operations manual of the Model 200.